Woo! Alright, here we go. We are going to finish up 8.2 today. Alright, this should be short and sweet, but usually when I say that, it's either short and never sweet, right? 8.2, last section, let's go back to the beads. If we want to be within 1% of the correct proportion, alright? So that means we want to really have our interval down to an exact science. You know, we only want to fall within 1% of the actual amount. How many beads should I have to collect if I want to be 95% confident? Okay? So, this is a problem you might see. They like to throw these kind of things on the AP exam. Basically, what this is saying is we had a probability of 0.2769. Okay? So that's how many blue and gold that we collected. Basically, what it's saying is I want to be within 0.01. I want to be I want this to be 0.01. Because that will be, I'm within 1%, right? That's the goal, to make that guy 0.01. Alright, so this gets into some algebra here. I love algebra. So this is my wing, really, right? And so I've got to know what my wing is made up of. And you should say, well, my wing is made up of my CV, my critical value, and my standard deviation. Right? So my critical value times my standard deviation should equal 0.01. That's my goal. That's my goal. Alright, so my CV, I want to be 95% confident, so I'm going to put 1.96er times a standard deviation. Remember, I don't want this all to be 0.01. I want it to equal 0.01. My standard deviation, alright, now here's the kicker. I know this should be 0.2769 times the inverse, and let's go 1 minus that, which is 0.72. Oh man, that was a big 2. 3-1. Sorry guys, I'm going off the bar. But here's the thing, is saying how many people should I sample to make sure? Because obviously the more I sample, the more narrower, the smaller my interval gets, right? Okay? So how many should I sample? So basically it's an algebra problem trying to get n by itself. Alright? That's really what I got to teach you guys here today. So what would I start with? Probably knocking this guy out. And divide by 0.96. Divide over here by 1.96. All algebra, just trying to get n by itself. I am left with a square root. You know, I'm going to multiply that top together. We're going to go times that, which equals... Roughly, when I multiply the top together, I get 0.2. Okay, close enough to 0.2 over n. Alright, that's if I multiply the top. And that should equal, well, 0.01 divided by 1.96, which is about 0.0051. Cool. Alright. So now, we're trying to get n by itself. I can't get in. I want to penetrate, but that force field is still up. How do I close the force field of the square root? I square both sides, ladies and gentlemen. If I square both sides, that square root doesn't have a chance. I'm going to be left with 0.2 all over n equals... I'm just leaving that number in calculator. When I square that, oh my goodness, it's something horrid. 4 zeros. 1, 2, 3, 4, and then a 2 and a 6. Alright. Now, I'm going to leave this in my calculator because I want exact answers. Okay. Now, here's the fun part. N is on the denominator. right? So you got a couple options here. You can do an easy drop under a 1, right? Because obviously everything's over a 1. And you can do cross multiply divide. That would be easy, right? You could do that very easily. Cross multiply divide, boom. Or you can do what every man, woman, and child should do when they do algebra and realize that, hey, if I multiply by n over here, I have to multiply by n over here, and I get that n out of the denominator, right? And then I can divide by 0.00026, and I will have n all by its lonesome self. So I'm going to divide this over here by 0.00026. All right, now I'm going to take 0.2 and then divide it by that ugly number, and I get roughly an n that equals 7, 6, 8, 3.2. All right, now let's think about this. If I want to be within 1, now it does matter on my rounding. This will be exactly a margin of error of 1. It's all algebra, guys. If I remove this 0.2, will that be a margin of error of 1? And hopefully you'll see, right? If I remove a little, it's going to get just a tiny bit fatter. You see that? Right? If I remove just a little bit like that 0.2, it's going to get like, oh, just a little move. It's going to get a little fatter, and it's no longer going to be 1%. It's going to be like 1.000001. All right? So I need to round up to 7, 6, 8, 3, 4, sorry. Whew. After I just got done. This, rounding up, will make it a little extra skinnier, which is fine. A little extra skinny is nothing wrong, right? It'll be a little bit less than 1%, but there we go. Now, some of you guys are thinking, this doesn't pass the independent test, and you're exactly right. Right? If this was real life, obviously I would not take a sample of 7,684 beads, because this doesn't pass the independent test, right? That's not less than 10%. But anyways, for kicks and giggles. All right, let's go. We'll do one more story problem like this. All right, so down here to number 3, it says, can you taste PTC? PTC is a substance that has a strong bitter taste for some people and is tasteless for others. It's kind of like rolling your tongue, guys. Some people can do it, some people can't. Look, check this out, guys. Really small. I can roll it like a burrito, and I can go like rojo, rojo. Ah, yeah. Okay, some people can't do that, I guess. My wife can't whistle. I can. I'm just talented. Okay, so how long? Alright, so about 75% of Italians can taste PTC. Go Italians! For example, you want to estimate the proportion of Americans who have at least one Italian grandparent and who can taste PTC. How large of a sample must you test to estimate the proportion of PTC taste testers within 0.04? So we want to have a margin of error of 0.04 with 90% confidence. Answer this question using, we're going to assume that that's going to be like our p-value, alright? That's what it's basically saying. So I want my critical value and my standard deviation, because this is my margin of error, right? I want this whole thing to equal 0.04, right? Because I want to be within, plus or minus, right? Plus or minus. So my CV, 90%. I don't have that one memorized. I'm going to have to go back to table B. And 90% is at 1.645. 1.645. So I'm going to go 1.645. That's my critical value. times my standard deviation, which is going to be the square root of 0.75. Thank you for small, easy numbers. Times the inverse of 0.25. I kind of like that when I multiplied these two on the top together, especially when I'm doing algebra. It really made it slick. Divided by n. That's really what I'm trying to find out. I don't know how many people I should sample. I want to be within 0.04 though, right? Algebra. Al-Khwarizmi. Algebra. Al-Khwarizmi. By the way, Al-Khwarizmi invented algebra. And we're going to just start knocking it out again. Check this out. Divide by 1.645. Divide by 1.645. Now 1 year, I had somebody actually write out the equation for this. And for some people, smart people, you could probably do that too. But I doubt you're going to remember it. 645. They solved it all out, so they had the n equals whatever, and you just plugged it all in. So I'm going to get the square root. Oh, hold on. Hold your shorts. I'm going to get 0.0243. Alright, that's on the side. I'm also going to multiply the top here, just so that can stay nice and dandy. And 0.75 times 0.25 is about 18. 75. Okay? At this point in time, I shall pick my purple and square root. Sorry, square the square root. And let's go. That will be squared, which will give me an ugly number. 0.1875 divided by n will equal an ugly number, 0.000591. We'll just go like that. Alright, and it's going to go on for a long time. I'm going to bring the n. I'm going to try and save some time here because I said it was going to be quick. I'm going to bring the n over here, which brings the n over here, right? So I'm going to divide. Basically, divide this side over here by this side. So I'm going to have 0.1875 end up being divided by 0.0000591. Something like that, right? Because I'd have to divide this side and bring it over to the other. That's going to be my answer. Let's check it out. Whew. 0.1875 divided by that ugly number, 317.1. Now remember, if I round down, it's going to get wider, and it's not going to be exactly 4%. It's going to be a little more than 4%. So I always want to round up, making that thing extra, just a little bit more skinny. I'm going to round up. The correct answer is I want to sample 318 people. If I sample 318 people, I should be within 4%. Ladies and gentlemen, it has been a pleasure. It is 11 o'clock for me, and I need to go to bed. You guys should be able to do all the rest. Don't forget your state, your plan, your do conclude. Oh man, it has been breathtaking. See you guys.